Hello and welcome learners. In this video, we will start with topic 8 energy production. We will understand what is specific energy, how to calculate that, energy density of fuel sources, and what is the relation between them. Also, we will practice some questions based on this. First, we need to understand sources of energy. So there are two sources of energy, primary and secondary sources. So what is a primary source? Sources directly used by the consumer from nature, like coal, wind, oil, gas, or water. As you can see here, we are burning wood in order to produce heat energy. So wood is considered to be a primary source. If you can look at this windmill, the kinetic energy of the wind is getting converted into the mechanical motion of the wheels, where we are using it in order to grind grains. So wind energy, that is also a primary source. Now let us look at secondary sources of energy. So energy transformed from a primary source is considered to be the secondary source. For example, electricity energy from hydrogen. So hydrogen is considered to be a very good source, as the byproduct in that particular scenario would be water. Now the question comes over here, which is how much energy we can extract from a certain fuel. To get the answer for that, we need to look at fuel-specific energy. It is the amount of energy that can be extracted from a unit mass of fuel. It is calculated by the formula Q by M. Then we will look at fuel energy density. It tells us about the amount of energy that can be extracted from a unit volume of a fuel. And it's calculated by Q by V. So as you are aware that Q is basically energy, and we calculate that with the unit joules, mass in kg. So unit for ES would be joules per kg. ED unit will be joules per meter cube. Now in this table, you can look at certain fuels, their specific energy and energy density. More the specific energy and energy density, better the fuel. Now let us look at a relation between ES and ED. So if you divide ED over ES, you will get M by V, that is density. So we can say ED is equals to rho times ES. Let us practice some questions based on this. Fission of uranium-235 produces 3.5 times 10 raised to the power negative 11 joules of energy. The density of uranium is this much. Calculate ES and ED of uranium-235. Firstly, ES equal to Q by M, where Q is given to us, that's 3.5 into 10 raised to the power negative 11.
In order to find the value of M, we need to multiply 235U with 1.661 times 10 raised to the power negative 27 kg per U. U get cancelled, we get the mass in kg. Once you get the mass in kg, divide that, you will get ES value, that is 9 into 10 raised to the power 13 joule per kg. Let us look at another question. We need to calculate ED for uranium-235 if density is this much and ES is this much. As we know ED by ES equals to density, we can write ED equal to density times ES. By putting the value, we can get our answer.